Hi guys, welcome back to Bright Future YouTube channel. My name is Kwadra Shawomba Shabanzila Shankanga Telaridweni. Nimduamba mina nchavinchum chabela maika. So today we are doing lesson number 2 of geography and continuing where we left off last time. So let's go to summer synoptic chat. So there's a figure below, which is figure 1.1.1e. shows a typical summer synoptic weather chart of South Africa. The features of summer synoptic chart to note. So they just give you a synoptic chart without telling you whether it's summer or winter synoptic weather chart. Then you need to look for tropical cyclone, look for that symbol on the synoptic chart, and then low pressure over the land, the date, the South Indian high pressure found southeast of South Africa is further south. Generally high temperatures over the land. So that's a summer synoptic weather chart. Where the notes that you should look for when you are analyzing your synoptic chart. So in here they decided to give you a weather station, to read a weather station for this. It's here, sorry. So it has temperature of 28 degrees, dew point of temperature 23 degrees, wind direction, wind speed, cloud cover, and precipitation. Remember, I showed you how to analyze this on our last session. Note the high temperatures at this weather station. So look at the temperatures on the map, and then it'll show you that this is a summer synoptic weather chart. And also the tropical cyclone is visible, the South Indian high pressures, the date as well, and the low pressure cell on land. For winter synoptic chart, you should look for cold fronts moving over the land, dominant Kalahari high pressure over the land, the date, the South Indian high pressure and the South Atlantic high pressure are closer to the land and further north. Generally low temperatures over the land. So that will show you it's a winter weather synoptic weather chart. So as you can see, the South Atlantic is towards the north and closer to the land, and South Indian high pressure as well is the same. And then you got cold front, and then you got generally low temperatures on land. And then look at the date as well. So they decided to analyze that weather station. It's got temperature 11, it's got dew point temperature of 6, wind direction, wind speed, cloud cover, and precipitation. Now let's go to 1.1.2, which is the global air circulation. These are winds that cover large areas over the Earth's surface. These are 3 global wind systems: the tropical easter lines, the wester lines, the polar easter lines. So a force called Coriolis force causes global winds to move to the left in the southern hemisphere and to the right in the northern hemisphere. So you need to learn how to draw and label the following diagram, and be able to define the Coriolis force. The tricellular arrangement, the pressure belt, and the global winds together form the global air circulation. So this is shown here. You should be able to draw this, the global air circulation. You should be able to label it for memory. So as you can see, you got polar high pressures on the northern pole and the southern pole. You got the polar easter lines as well, closer to the subpolar low pressure. These lines as well. and then they're closer to the subpolar low pressure, and then you got the western lines, and then they are closer to the subtropical high pressure, and then you got the tropical easter lines, which are closer to the intertropical convergence zone. We did define this one last time, which is on the equatorial low pressure. You should be able to tell this is a polar cell, the feral cell, the Hadley cell, and this one as well, the feral cell and the polar cell. You should be able to draw this. Should be simple, because as you can see, what happens on the northern hemisphere happens on the southern hemisphere until they meet at the equator. So that's how you can actually analyze it. Let's go to cyclones. We're gonna start with mid-latitude cyclones. We'll look at mid-latitude cyclones in more details. We focus on the cross-section through a matured mid-latitude cyclone and the weather that occurs as a result of the cold front. This is the most frequent tested session, as South Africa is mostly affected by the passage of cold front. So figure 1.2.1a shows a cross-section through a mid-latitude cyclone. You should be able to label and sketch the cross-section from a synoptic view as shown below. So let's go for it. You should be able to draw this and label it and describe it. So this is your mid-latitude cyclone. As you can see, it's a cross-section from A to B. You have your cold denser air moving this direction. You also have air, cold denser air moves under warm air, and then here you have warm air rising above the cold air, which is going this side. And then here we've got the warm front. Here we've got the general movement of the system, which moves that way. And then we've got the cumulonimbus cloud, and then we've got the front, the cold front. So let's move to the description of it. As a mid-latitude cyclone moves towards South Africa, it is the cold front that mostly affects our weather. Weather in front of the cold front. So now we're going to analyze the weather in front of the cold front. So which is point 1. It's this point. We want to analyze weather in front of the cold front. You generally have cold temperatures. Oh, I'm sorry about that. We have cold temperatures, very low pressures, overcast condition, cumulonimbus clouds, thunderstorms, and then the weather behind the cold front, which is point 2. This point, it's cold temperatures, high pressure, partly cloudy conditions, cumulus clouds, and then we've got light rain. That is the weather behind the cold front. So note that as a mid-latitude cyclone moves from west to east, we experience the warm air mass in front of the cold front first, then the air behind the cold front. This can be seen in figure 1.2.1a above as you move over the point 2.1 to 2. So we experience warm air mass in front of the cold front. Here is warm air rising in front, and we've got cold air behind. So you should be able to know this. You should be able to draw this. So I would suggest when you're practicing, you draw this and you label everything that is in here to get your full marks. And then now let's go to figure 1.2.1 below, which shows the weather conditions before and after the cold front. So you see the cold front the cold front, in front of the cold front, and behind the cold front. So these are weather conditions before and after the cold front, right? So in front of the cold front, you got very low pressure, overcast, cumulonimbus cloud, and you got heavy rain, as you can see. And then behind, after the cold front, you have cumulus clouds, high pressure, partly cloudy, and you got light rain. You should be able to draw this one as well. Now this is the real picture or the satellite image of a mid-latitude cyclone. So now let's go to a tropical cyclone. A tropical cyclone is a type of a low pressure system which generally forms in the tropics between 5 degrees and 30 degrees north and south. It is accompanied, if you're able to draw that diagram that I showed you, you'll be able to see where tropical cyclone usually occurs. It is accompanied by thunderstorms and circulation of winds near the Earth's surface, which is clockwise in the southern hemisphere and anti-clockwise in the northern hemisphere. Tropical cyclones are also known as hurricanes in America, typhoons in China and Japan, and willy-willies in Australia. Tropical cyclones are given names alphabetically within the season in which they occur. For example, Alfred will be donated in the will donate that it is the first tropical cyclone to occur in that season. So that is very important for you to know. If they say it's Caroline, it means it shows that it's the third tropical cyclone to occur in that season. Now let's look at the tropical cyclone in more detail. So in order for it to occur, the temperature of 25 the temperature should be 27 degrees and more. The Coriolis force should be there, should be present. There should be enough moisture and then less function. Okay. So now this figure shows a cross-section through a tropical cyclone. In this one as well, you should be able to sketch it. As you can see, you got big cumulonimbus clouds, and even here you got cumulonimbus cloud, and here you got cumulus, and then in here you got the eye of the cyclone. Here you got low pressures, here you got S going down, which is subsiding, and then here you got thunderstorms. You should be able to draw this and label it from A to B. Now the characteristics of mid-latitude cyclones and tropical cyclones. So this you'll be able to tell which one is tropical, which one is mid-latitude. So in an exam, sometimes they ask you in this format, in a multiple choice question, they would say name another, give us another name of a mid-latitude cyclone. So it's temperature cyclone. And then you'll be asked again, maybe in this way, list 2 characteristics of tropical cyclone, which is it has an eye in the center, it's accompanied by thunderstorms. And then they'll also ask you to draw a cross-section area, cross-section from A to B. For example, 2.2A and 2.2B, the one that I just showed you for mid-latitude and also for tropical cyclone. So that's how they actually ask the questions for this section. Now these are the characteristics. So mid-latitude cyclone and tropical cyclone, as you can see, you got 2 tables. So other names for mid-latitude cyclone is frontal depression, temperature cyclone, extratropical cyclone. So you need to know those names. And for a tropical cyclone, it's hurricane, typhoons, willy-willies, and then they're named alphabetically at the beginning of each season. The formation, they occur, mid-latitude cyclone occurs in 40 to 60 degrees north and south, and then tropical cyclone occur in 5 degrees north and south. I'm sorry, it's the formation, it's where they formed. Now they occur in 30 to 60 degrees north and south, and then a tropical cyclone over tropical oceans, which is in 5 to 30 degrees north and south. The movement, mid-latitude cyclone, they move west to east. It's driven or it's pushed by western lines. And then tropical cyclone, they move from east to west, which is the opposite of mid-latitude. It's driven and also pushed by east. So the season in which they occur, mid-latitude cyclone occurs all the year round in both hemispheres, affects South African in winter. And then tropical cyclones occurs in mid to late summer and early autumn. Identifying features for mid-latitude is that it's warm front, warm sector, cold front, cold sector. And then for tropical cyclone, it's stormy weather in the vortex. The eye is a calm, intense low pressure cell. Sorry about that. The weather for mid-latitude cyclone is associated with a cold front, overcast, low temperatures, strong winds and heavy rains. For tropical cyclone, it's warm to hot, violent winds, intense thunderstorm activity. Areas affected is the western side of continent in mid-latitudes and eastern side of the continent in tropical latitudes. Now let's move on to this. This is very important for you to know the synoptic view of tropical cyclone and mid-latitude cyclone. So you need to be able to identify this in an exam question paper. You can see you go for mid-latitude cyclone, this one you got cold front, cold sector, and then you got warm front, warm sector, and then you got obviously for both of them, because they are low pressure cells, the numbers increases as you go out. Remember, there are also isobars. They're called isobars because they increase from inside towards the outside of the cyclone. And for synoptic view, for tropical cyclone as well, it's the same thing. They increase from inside going outside. You should be able to know these two. You should be able to identify them. As you can see, that this is the mid-latitude cyclone and this is the tropical cyclone. You should be able to identify them in a map, or you should be able to identify them as an individual figure. So this is the map. This is the map. A South African Weather Service. We're not gonna analyze it though. So I want you to know, yeah, now this one, it's the satellite image of a synoptic weather chart of the same day. So this figure is of the same as this figure. It's just different. Sorry, it's a different chart. So we are done for today's session. Thank you so much for tuning in. When we come back again next week, we'll start from factors affecting the South African climate. I would really appreciate it if you subscribe, you share with all of your friends, and you like this video. And then if you have any questions, please put them on the comment section below. I'd really appreciate your engagement. Thank you so much.